Hello guys, welcome back to my channel Maison African Motives. Still working on engineering science and 4. So in this platform we shall have a continuation from the previous classes that we had. Still working on question papers and revisions. So in this platform we are going to work on kinematics, which is actually from the question paper which was written in February 2022. So there we are given a question 2.1 that a river flows in a southeasterly direction. Take note guys, southeasterly. Whenever you're given such type of a direction, know that the angle that you're going to have is 45 degrees. So it will be in between like this, south 45 degrees to the east. That is what southeast represents, right? If it is northwest or northeast like this, it would be north 45 degrees east. All right, so this is south 45 degrees east. That is where the river is flowing, and while a boat crosses the river in the southerly direction. Okay, so you have a boat, so a boat is just going direct in the south direction. In ideal circumstances, the boat sails at a velocity of 8 meters per second. That is when there is nothing that is affecting techno. These are ideal, which means without the influence of the velocity of the river, which way it is flowing. Okay, then a river flows at a velocity of 5.6 meters per second. The boat's destination, that is the final distance the boat is going to travel, is 1,200 meters away. Calculate the following, the resultant of the boat. All right, this is what we are going to have, guys. We've got two things here. All right, we said the river is flowing in the southeasterly direction. Let's just have a sketch of what is happening here. So normally, let's just say we have our north and the North Pole. Remember, from the North Pole, guys, this is actually our northeast, this is our west, and this is our south. Okay, so the river is flowing with this southeast, and we said it's a south 45 degrees east. So southeast is in between south and east, that is in between these two. All right, so this is going to look like this. From this point, this is your southeast, just in between. All right, so this is what you're going to have from this point. This is where the river is flowing, and the velocity of the river is, take note, the river has got a velocity of 5.6. So this is actually 5.6 meters per second. So let's just say this is our river. So R for the river, take note guys, this is our river here. All right, let's just put this in a bracket. All right, and the boat itself is going in the southerly direction. Take note, southerly, that is straight to the south. Okay, this is going straight to the south like this, straight to the south, direct, because this is our south pole. So this is where we are going to have our end. So remember guys, we said south east is south 45 degrees east, which means from the south to the east here there is an angle of 45 degrees. But this one is not the one that we are worried about. We are worried with the angle which is between the horizontal and the velocity, which is this one. This is the angle that you are worried about. But we know that this is 90 degrees, this angle. So if this is 45, we are just going to subtract this from 90 minus 45 degrees, which is actually 45 degrees. So this angle here is going to be 45 degrees. All right. Then we have got the boat now. The velocity of the boat, this one, is 8 meters per second. So this is 8 meters per second. This one is for the boat. Let's just write B for the boat. All right, so that's our diagram, guys, and the question is calculate the resultant of the boat. So as you can see, we are having like just like what you have, guys, when you're working with forces from your N3 level. You worked with forces where you can find the resultant, the the horizontal and the vertical components and so forth. So that's the same thing that you can actually do in this case to find the resultant velocity. So remember, horizontal components, always you use cos theta. So the horizontal, okay, this one is going to be in the horizontal like this, because as you can see there is an angle 45 degrees. So this is the horizontal, which is going to be cos, so it's 5,6 cos 45, because it's going to be here. So it's going to be 5,6 cos 45 degrees like this. All right, that is the only horizontal that you can have because there's an angle. If we are to cross check, we do not have any other force here. We are only having this force, but this force is direct in the south line, which means this cannot be a horizontal, it's a vertical. This one is a vertical, it is straight. This is a vertical line, this is a horizontal line. So this is what we have, guys. So this can never be horizontal, so it will be a 0, this one. So you're going to add a 0 there. There's nothing, it cannot be a horizontal, it's a vertical. So if you use your calculator, you're going to obtain this decimal 3,95 97 and so on. Okay, so you can round off to 3 decimal places, which is going to be 3,1, that's 1 2 3. So this 7 is actually going to change this 9 into 10, and this will give a 1 here, which is going to be a 6 there. So it will be 960 like that. Okay, which is the same as 3,96. That's the velocity, which is meters per second. So this one is going to be in meters per second. So as you can see, the horizontal is a positive, and like I said, that's how it can be horizontal. So if horizontal can be positive or negative, and to the positive, as you can see, this is to the east and this is to the west. So when it is a positive, it is going to the east. So this is going to the east. All right, we just do the same for the vertical. So this is the horizontal. Let's just say H component, that is the horizontal component. Okay, then we have got the vertical components. The vertical components in this case, which is going to be sine theta, always horizontal, it uses cos theta. Vertical uses sine theta like this. All right, so let's just put this. This one can be a vertical, as we can see. This one, it's a vertical here, it's a vertical here, it's a vertical. This is the horizontal. So this vertical is below like this, it's below the x-axis is here, so it's going to be a negative because it's below this side. So it's be a negative, but it will carry a sign. This one will carry a sine theta, but it's a negative now. So it will be minus 5,6 sine 45 degrees. Sine 45 degrees. Okay, this one also is a negative. As you can see, guys, it's a straight vertical, but it's pointing downwards, which is a negative like this. For the vertical on top here, it's positive, down it's negative. So it's going to be a -8, a straight -8. That one is a straight vertical line, so it's just going to be a -8 like that. All right, sorry. So using your calculator again, you are going to obtain this decimal, guys, minus 11,95 97 and so on. So you can just round off to 3 decimal places. You can see these decimals are the same as these ones that we had, so it's going to be minus 11,96 meters per second. Okay, so what is this negative representing? Negative is representing the direction, to show that it's in the south direction, because vertical can be north or can be south. So the negative just indicates that it's in the south direction. So you are going to write it without a negative. So you write it as 11,96 meters per second south. So the moment you write the direction, you have already indicated the sign. This direction consists of the sign. This direction consists of the sign. So the moment you write east, you don't write the sign, because already you're indicating that you're going to the east. So that is how you're going to have. So we have got the horizontal component and the vertical component here. So let's find the resultant. So remember that you find the resultant from you're just going to have your triangle like this, so that you actually know where you're going to take the angle. Okay, this is the purpose of the diagram, guys. This is horizontal, it's going to the east, so you're going to have this one to the east, and vertical is going to the south, which means it's a negative. So is this going to lie in the fourth quadrant, where horizontal is positive and vertical is negative? It's in the fourth quadrant, this one. So that is where your triangle is going to be located, like this. All right, so this is the horizontal, which is 3,96. This is the horizontal 3,96, like this, and this is your vertical here, which is 11,96. So the negative, it does not matter because already it's in the down, which is a negative. Okay, so this is going to be the direction, which is theta, and this is going to be the resultant. So this is the direction, this is the resultant. So as you can see, it's in the east versus south. So your angle is going to be east theta to the south. So that is going to be our resultant. So as you can see, guys, to find the resultant, definitely we know that the resultant is equivalent to the square root of hx squared plus vy squared. So that's the resultant, is the square root of the horizontal 3,96 squared plus the vertical squared, which is 11,96 squared. So you're going to obtain something like 12,598 5985. So it's going to be 599, all right, meters per second. All right, so we've got the resultant. Then we need the angle theta, and we know that theta is equivalent to arctan, the vertical component over the horizontal component. This is actually from your N3 engineering science. So you can also watch the videos on N3 engineering science under this platform, so that you can know the recap if you didn't like yet engineering science N3, just started it N4. All right, that's it, guys. So we're going to have arctan. In this case, that's the vertical, which is 11,96 over the horizontal 3,96. So this is going to give us an angle of 71,6801 and so forth. So it's 6801 and so forth. So it's going to give us 680 there degrees, which is just 68. So like I said, guys, therefore our resultant is going to be this 12,599 meters per second. Okay, then the direction, which is this theta, this is the direction. Okay, this is the resultant. So always it's a vector sum, it's a vector quantity which has to have the magnitude and also have the direction. So you're coming from the east to south. This is east going to the south, but which angle are you going to approach? It's east 71 degrees, 680 degrees, 71,680 or 71,68. You cannot write this 0, it's not a problem, you can write it, but you're going to the south. So this is what is important. Or if you can write from the south, it will be south, you subtract this from 90 degrees. If you want to use this direction south, it will be 90 minus theta to the east. Okay, if you use that one, so you subtract the theta, which is this angle, or you just use this one. So that was it, guys, on the resultant of the board. That's how you calculated it, and the time it takes to reach its final destination. So the time now, since we've got the resultant velocity, it's now easier for us to calculate the time. Why? Because we are given the distance the boat travels, which is the destination of the boat, which is 1,200 meters. So you know that time is equivalent to, so this is time which is equivalent to the displacement. That's the displacement over time taken. No, we need the time, guys. This is over velocity. What am I talking about here? Over the velocity, sorry, which is the resultant velocity actually. All right, so the displacement, that's 1,200 meters over the resultant velocity, which is 12,599, the one that we obtained here. So you can divide by 12,599, and this is gonna give us a certain decimal 95,252456. So you can round it off and it will give you 95. It is going to give us something like this, guys, 95,246. All right, because this is 2456, so this 6 is going to change this into a 5. And we are calculating the time. This was in meters, this was in meters per second, so definitely our time is going to be in seconds. So that is what you're going to have. We are not told to give our time in minutes or in hours. We're just going to leave our answer in seconds as it is. Okay, that is how they can ask these questions, guys. Then the other question is, two friends depart from a college to their respective homes, which is on 2.2. Tuso rides a bicycle at a velocity of 6 meters per second in the direction west 25 degrees south. Bakan walks at 2 meters per second in a direction of north 50 degrees east. Calculate Tuso's velocity relative to Bakan. And we've got 5 marks for that. All right. What are we going to do in such a typical question, guys? What are we going to do? All right, let's just say these two friends, they are starting at this point here. All right, let's just say this is their starting point. All right, this is 2.2. Okay, let's just say these guys, they started at this point here. All right, so where they started, I'm just gonna indicate like this, where they started, so that we can clearly understand what happened to these guys. So I'm not putting bold lines, I'm just going to use broken lines so that we can understand what is happening here. All right, so this is the case, guys, where we have got our north, our east here, our west, and this is our south. All right, so this, the first one, which is 2, so it rides 6 meters per second west 25 degrees south, which means this is our west and this is our south. West coming to south, so which means it's in between west and south. This is where we are going to have it, between west and south, like this. So this is just somewhere here. Let's just put it somewhere here, guys. All right, we've got something like this. All right, so coming from the west going to the south, so this is like this. This is where we are going to have an angle of 25 degrees here, and the velocity of the guy is 6 meters per second. So this is going to be 6 meters per second. Take note, they are going this way because this is where they are all departing from. These two guys, they are from the same point. Let's just say this is point C. Okay, then what happened with the other guy, which is Wakang, walks 2.5 meters in a direction north 50 degrees east. This one, okay, so it's north 50 degrees east. That is north 50 going to the east. So it's between this quadrant of north and east. This is where you're going to have it. Okay, let's just put it this way so that we don't confuse each other here. This is going to be like this. All right, so as you can see, guys, we are given an angle of north to east, so the angle is going to be in between here. This is where we have the angle of what, of 50 degrees from north to east, but always we want the angle, this one, so we are going to find this angle here. All right, between this east, remember between the north and the east we've got 90 degrees here, so we're going to subtract, that's 90 minus 50, which is 40 degrees. So we've got 40 degrees inside there. All right, so that is what we have, and the velocity of this other guy is 2.5. As you can see, the velocity is 2.5. So this one is got a velocity of 2.5 meters per second. Okay, so this is Tuso, okay, and this is Bakang, so just write it as B like that. All right, you've got Tuso and Bakang like that. These are the two guys that we are having. Okay, so we are going to join the two here. so that we can find the relative velocities that we are given. So I'm just going to join this one. All right, this is what is going to happen, guys, after joining. So the question is asking us to calculate the two source velocity relative to Bakang. So which means the one that we are relative is this one, which is Bakang. This one, this is the guy whom we are relative to, which is here. So where you are relative to, you're just going to have your North Pole where you are relative to here. Just draw your North Pole. I will explain later on about this North Pole that you're going to have here. This is where you are relative to. So you're going to take this point as your reference point. Okay, but this is going to be like this. It's a torso relative to Bakang. So this is the part that you're going to have as a resultant there. So how are we going to calculate this resultant here? So we know that if this is 6,5, it actually means this line is actually 6, not 6,5, guys, 6, and this one is 2,5. That is what it means. So you can actually use cosine rule to calculate this if we can manage to obtain this angle that I have indicated at point C. This one is just any point. You can write it as A, B, C, whatever that you want. Okay. So if we are to cross check, guys, we are supposed to have this whole angle, this one. We are supposed to calculate this whole angle that I have indicated there. But so far on this angle, we only have 40 degrees, which is inside, and this 90 degrees here, because we've got this line between the south and the east. Between the south and the east, there's an angle of 90 degrees here. So you've got 90 degrees, and this angle between here, between this 6 meters per second and the south, this is the angle inside the triangle, this one. You have to find this angle. So how do you find this angle? You subtract from 90, because this is 90 degrees also. So it's 90 minus 25, which is going to give us something like 65. 90 minus 25, which is 65 degrees. All right. So therefore, this whole angle at C, let's just say the angle C like this, is going to be this angle, which is 65, plus this 90 degrees that I indicated from the south to east. There's an angle of 90 degrees, plus the 40 degrees, which is this one in between, the one that we've calculated from 90 minus 50, there is 40. So we're going to add 40 degrees also. So this is going to give us 195 degrees. So that means this whole angle inside the triangle, this one, is going to give us 195 degrees. That is this angle here inside the triangle. Okay. Why are we calculating this angle? Because we know that to find this velocity, we are going to have this from, let's just say, since we say this is C, we are just going to have this as small letter C like that. Okay, so we know actually that when you are using cosine rule to calculate the side, this is what I'm going to write it down, guys. You must just know this. A is equivalent to the square root of b squared plus c squared minus 2bc cos A. Actually, this formula, guys, whether you're calculating C, you're calculating B, you just use this formula. What you just need is to know what does B and C represents. These are the sides which create your angle, this side and this side. That is your B and C. And this A is the angle which is created by the sides, which is this angle of 195. This is the angle created here. So we're talking of this side, the sides like this, which are creating the angle. This is the condition like this. All right. So these are the sides. So we are going to apply our cosine rule to calculate the resultant here. So I'm just going to write it as R, which is equal to the square root of b squared plus c squared, which is 6 and 2,5. So you've got 6 squared plus 2,5. This is 2,5 squared minus 2 times b, which is this b6, and c, which is this c, which is 2,5. As you can see, b and c we are just repeating, but you've got cos A, which is cos of the angle of 195 degrees. All right, so that's what you're going to have, guys. So from your calculator, you are going to obtain something like 8,3, no, 8,43. Yeah, this is 8,439 and so on and so on. So let me just write it because already I've written these three. So it will be 9654. Yeah, something like that. So 6 is going to change this into a 10, and we're going to add a 1, which is going to be a 4. So it's going to be 8,440, which is just the same as 8,44, which is in meters per second. Okay, so that is what we are going to have as the two source velocity relative to a car, which is this one. But we need to know the direction that is going to be taken from, because we are relative to Bakan. That is why I had this North Pole here. So this is the direction that you're going to take. There are two options. You can take this from south to west, this one, south to west, or you can take this one. Since this is west and this is south, you can take from west to south, this angle here. This is the angle that you're going to take. But as we can see, we can't determine this angle direct. Do you have any way that we can use, guys, to actually determine this angle direct? We do not have. So what are we going to do in this case is actually to calculate this angle. We can actually maybe have this angle at B, this one, which is inside B. I want you to see the angle that I'm indicating there at what? At B. So this can be the angle that you're going to take here, this one, at B. So to find this angle at B, definitely you're going to use this concept this time. Instead of using cosine rule, remember from sine, you've got this angle here, it corresponds with this side. This angle here corresponds with this side because we found this resultant. We found it is 8,44. So this angle also corresponds with this side. So from your trigonometry in mathematics N3, you worked with a non-right angle triangle where you had a concept of sine A over A, which is equal to sine B over B, like that. So you can actually use that concept since you want to calculate this angle at B. So it's going to be sine B over the corresponding side, which is this one, 6. So this B, angle B, corresponds with 6, which is equal to sine the other one that you're given this angle and the corresponding side because we calculated it. So it's going to be sine 195 over the corresponding side, which is 8,44. So this will be 8,44, like that. So guys, from your mathematical skills, you want to calculate this B here. So you can actually remove this 6, just multiply by 6 both sides. So this is gonna cancel here. So which means we are going to be left with sine B equivalent to 6 times sine 195 degrees over 8,44. That's what you're going to have. And from your mathematics, guys, we know that if you are given maybe sine x is equal to 0,2, to find x, you're just going to use arc sine 0,2, which is shift sine. So that's B is going to be arc sine, this value 6 sine 195. You can use it as a decimal, or you can just use it at this stage like this, or you can just find a decimal, then you just shift sine from your calculator. So it's shift sine, the value that you're going to have. I don't know if it is clear like this. That's shift here. Then the moment you write shift sine, as you can see, it has got a negative there. Then you put in everything that you're having. So this is going to give you a negative 10,603 degrees. All right. So this angle B that we are calculating, what is it gonna help us? Why are we actually calculating this angle B here? Okay. There is one thing that we are so much certain about. The angle that I was indicating, guys, is supposed to be this one. From the red to the red, this one, guys. From this red line, this one, to this red line, this one like this. All right, this is the, remember, when you are calculating the direction, remember the direction, it's from the either, but mostly what I want you to know is that you take it from the horizontal line. So if you take it from the horizontal line, it must be from the horizontal line to the resultant line. To the resultant line, that is where the angle, this is your resultant, this is your direction, this one, from the horizontal line to the resultant line. So the purpose of us calculating this B is this one that is in red, this one that is in red, this one. So why did we calculate this angle B that we just calculated now, which is minus 10 comma what according to what we obtained? Because if you are to cross check, this angle here is 40 degrees here, this angle is 40 degrees, and this angle that is in between here is also 40 degrees. I'm going to, let me indicate it in black, or let me put it this way. I think it's gonna be much clearer, guys, for us. This angle here, this one, this is the angle that I'm talking about here. This angle that I've indicated right now, this angle here that I'm indicating here, this one, and this angle of 40 degrees also that I'm indicating here, of 40 degrees, these two angles here, they are equal. These two angles, they are equal, this angle and this angle, so which means this angle is also 40 degrees. From which concept? From the concept of parallel lines. Remember, from the parallel lines like this, if you draw a transverse like this, this angle and this angle are equal. They are called alternate angles, the ones which create a Z. So as you can see, we are creating a Z here, so this is also 40. So that means we are going to take this 40 degrees and add it to this angle that we just calculated now. That is what is going to happen. So that means the angle, finally the angle is going to be 40 degrees plus the other angle. Okay, so it's going to be 40 degrees plus the other angle that we obtained, which is this one, which gave us a negative, this one. So we're going to add negative 10,603 degrees like this, which is going to give us 29,397 degrees. All right, so this is what you're going to have as the direction. Remember, the theta is representing the direction. So which direction are we talking about here? This is the west, because this is east, guys. This is west, south. So it's from the west to the south. So it is going to be west 29,397 degrees to the south. All right, so that is what we are going to have. So therefore the answer now is going to be what we are being asked, the relative velocity there, okay, which is going to be, remember we obtained 8,44, so it's going to be 8,44 meters per second at, which is the direction. So the direction is west 29,397 degrees south. So this is going to be our final answer. So every time you have this type of a question, you will actually need to know the basics. So it's actually took us a lot of time, because I was trying to explain some of the basics actually, which I wasn't supposed to be explaining. I was just supposed to answer the question direct. So that's it, guys. We shall have more classes on engineering, science, and for like this, working on past papers and revisions till we meet again.